Right, so the working process has begun. The car is on the lift. We have already dismantled the wheel and also the right front caliper, brake disc and a protective shield. The required part is covered with a protective tape. The rear axle consists of flowing caliper with servomotor initially. The front axle is a 6-piston caliper by Brembo, composite brake disc and an aluminium hub part on pins. Actually, the whole design is quite well done, but the size is smaller than required for this power and mass. Here we will have a bracket installed, as we are about to show you. Now I will tell you how the design of the braking system is being developed. The car arrives, we dismantle a braking disc, the default braking system, and eventually we see a marvelous aluminium knuckle by Maserati with radial binding of braking caliper. The caliper is a default 6-piston one, but for quite a small braking rotor. For technical task we have to use a carbon ceramic rotor sized 440 by 40. We place it for a correct angle by Z-axle. Then a hub part is designed and this assembly is practically done. Then we have to line up a brake caliper. Here we will have a 6-piston caliper by Brembo with dioxide zirconia insert. Initially, the caliper is installed with binding the caliper behind the axle of the car. And as we plan to install it before the axle, we will have to change polarity. That is why we unscrew these fittings here and place them on top, whereas the tube is placed below. For now it is not seen here, as we still have to recess in this spot. The caliper is already colored. In order to fixate the caliper, we need to design a bracket. It is identified with a blue color from aluminium. It fixates our caliper with 2 screws. Like this, 12 by 50. Firstly, it is installed to the knuckle. Then the caliper is fixated onto the bracket. Then we have to design a protective shield, which is installed in order to guard the whole construction from the dirt and snow in winter times. Completely safeguards the insides of the construction, consists of 2 plates and is fixated with few screws. After all of this is complete, there comes the fun part, to see how all this connects to the wheel disc. The wheel disc, may I remind, is 21 by 9. Seems to be no gaps here, everything's fine. The design work is done. This is our new machine tool, locally manufactured by the way. The machine tool mesh complex from Tver. Here the outside body of the caliper as well as 2 settings are being manufactured, first and then the second one. Here how this part will look like on the caliper. And here it is after electroplating, colored, but not yet assembled. Now we will remove it from the machine. This blank goes here, as this is the first setting to do the contour. Then the part is moved here into the vise for finishing touch. Here is how it looks when it's ready. Here we have done the coloring of the caliper, but before the coloring is done, everything is disassembled, of course. Pistons, pins are removed. The surfaces that do not need coloring are covered, so the mating plane here and bungee bolt here, and of course the piston sumps. The rear caliper almost always comes with an aluminium piston. Here's how it looks. For the front caliper, if the carbon ceramic rotor is used, The temperature of the rotor can go up as high as 600 degrees Celsius. Therefore, in order to minimize the transfer of the heat from the piston to the brake fluid, this heat insulation insert is used. That is being done from zirconium oxide. For example, this is a used piston. As you can see here, everything is burned out. See the cuff? It's almost gone to stone. The insert from zirconium oxide looks like this. It is actually quite a solid material, which cannot be said about this piston. Take a look, it falls apart pathetically. To me, this piston has done its job and probably was heated up to 400 Celsius, maybe even more. This line up here are the pistons for the front caliper. They are of different diameter. And this here is the ring of square section for hydraulic sealing. And these are protective dusters. This is the rear axle. Here the piston is more simple, done from aluminium alloy and coated. The front rotor 440 by 40 is already assembled, checked, all fine. Now we will be assembling the rear ones. The rear one is 410 by 32. The hub part has been engraved and signed. Now we need to insert bobbins in the hub part, and it is done like so. The principle of this assembly is that the bobbins move relative to the hub part. This is done in order to compensate for the difference in thermal expansion of the materials. The hub part is titanium, but the rotor is ceramic, and with temperature rising, there is a tension if the bobbins are fixed too tight. And this design here allows for some space to be maneuvered. Install the washers, and now we need to gracefully position the whole part. We double check that everything is firmly in place.
Yeah, you better. Yeah, you better. Yeah, you better.
We have finished the installation of the brake system for the vehicle Maserati Levante. For the front axle we have a rotor 440 by 40, a 6-piston caliper, carbon ceramic brake system, a hub part is titanium. All our required attributes like protective shields and brake tubes are present. It is important that all the default functions work flawlessly. That is why we use the default sensor for the brake pad wear. Here is a fixed connector on this bracing, and here we see brake tubes. We also install this small plate for the owner to know what temperature this carbon ceramic brake rotor was heated up to. For the rear axle we use the brake rotor 410 by 32, a 4-piston caliper and a parking brake caliper. All functions perform as by default. We also marked it to control the allowance of the maximum temperature. The front axle is equipped with a carbon ceramic brake system as well as the rear axle actually. Caliper is installed to the aluminium bracket. It has been electroplated and colored after. and also this protective shield. The brake tube is laid through default brackets, as you can see here. Now onto the rear axle. This is a 4-piston caliper which is responsible for hydraulics. Here is the brake tube and a sensor for brake pad wear with biding. Default manufacturing. All this is being fixated by 3 screws and some collars. It is important to protect the rotor from dirt, sand and water. And here we have a parking brake caliper. The hub parts are titanium, designed and done by us.